So what we're going to be doing today, we are going to continue with chapter 7. There are a few points left from last class. We didn't have time to cover them. So today we're going to go through them and cover them all. But before we do that, I'm just going to share my screen with you guys because what I want to say is that next week we will have the first test. And for the class of Tuesday, what we're going to do, we are simply going to go through a review about that test. I'm just going to tell you from now that the exam is going to be two parts. One of them is going to be true and false questions, half, and the other half is going to be a programming question. Now, what I did, I provided, let's see here. There's a guide here just to give you an idea about what the exam is going to look like. It's a very short guide here. You can have a look at it, tell you what chapters are included. Just to let you know again, from chapter 3 to chapter 6, the multiple choice questions part is going to include all of them, but the programming question is only going to include chapter 3 and 4 and 5. So that was one thing that I want to mention. And the other thing that I want to mention is that I have a question here. It's a sample of what would the question is going to look like. Of course, it's not going to be the exact same question, but something very similar to what we have here. So you do have it here. You can have a look at it. You can try with it. What I'm going to do on Tuesday is that I'm going to try to answer this question, and I'm going to cover every single possibility change that could be applied here. So that should help you when you prepare for that exam.
I have a question.
Yes?
Is the test in the lockdown browser?
Is it what?
Is it in the lockdown browser?
I'm not sure yet, but here's what you can do. The exam is going to be two parts. The first one is going to be done using the Canvas page, and that part is going to be a lockdown. And the other part is going to be a programming question. So what you're going to do, you're going to open your Eclipse or whatever the IDE that you're using. You write the program, you execute it, you copy it, and you upload your answer.
Okay. And also, what resources will you have to review for the test?
What is that again?
Where should we look to study for the test?
I'm going to be talking about that on Tuesday. But just to give you an idea here is that the exams is going to be about the first 3 and 4 and 5 and 6 chapters. But the programming part is just going to be 3 and 4 and 5.
Okay.
Topics, again, the programming question is going to be very similar to the one that I'm sharing right now. But for the multiple choice questions, I'm going to have to go through them and see what topics to focus on. So I'm going to provide that later. Did that help?
Yeah.
Okay. Okay, so with that being said, we can continue with what we started last class. So let me just jump straight to Eclipse. Okay, so last class we talked about classes, and we said we had the book class as an example. We provided here our data members, and then we talked about constructors. And this is the constructors. And then after that, we created, this is also a constructor. And then after that, we created the setters and the getters. And then we said the setters specifically sometimes give you a choice to control what values should be assigned to data members. So you will have full control over that. And we used set the number of pages as an example here. And then after that, we talked about how do we test for equality between two objects. And we said you're not supposed to use a double equal to compare two objects, and explained why double equal is not acceptable to compare the equality of the objects. And we said you should have a method to actually compare data members of the two objects. And whenever they all match, that simply means they're equal. If they don't match all of them, it's going to return as a false, as they are not equal. Then after that, we talked about the two-string method and the job of the two-string method. It's simply to allow you to print the object in the format that you want when you just use it with a system out print line. Now, my next point here is going to be about what we call static methods and static data members. what is a static method and what is a static data member? Well, let's just go and look at those members here. Sorry. If I look at those members here, those are considered non-static members. And non-static member simply means when you create an object, for example, B1 and B2 and B3, each one of those objects will have a title, author, published year, ISBN, price, and number of pages. Static members is simply when you create a property or you create a method that simply belong to the whole class. It's not a piece of information that's related to one object's, and that value will change from one object to the other. For example, like the title. Every single book has a title, but what is actually the title is different from one book to the other. So the title here is what we call a non-static method. But a static method is simply when you describe a property or a method that simply belong to the class book, not to a specific book. And I'm going to give you an example here so you'll understand what I'm talking about. Let's look at the price here. That price, every single book has a price, okay? And that price can go $10, can go $100. So we know that every single book will have a price. But here's an idea for a static member. There will be a tax that will be applied whenever somebody's buying a book. Now, that tax is not a property that belongs to a single book and that is different from one book to the other. For example, you're not going to see the tax for one book different than the tax of the other book. The tax on the books is simply going to be a property that belongs to the class overall. It's more like it's shared by the whole class. So that's what we mean by static members. In this example here, I'm going to have two static members. One of them is going to be the tax rate, and the other one is going to be a counter that will count how many books we are going to actually create. So let's start with that. How do we do that? Let's start with the tax. I'm going to go private. And I'm going to go, for example, static. It's very important to use the keyword static. And then what is the data type? For example, I'll go double. And I will call it tax rate. Tax rate. And if I put semicolon here, it's recommended here, of course, to assign it to value immediately. So here it is. That's my tax rate, 10%, for example. Now, if I want to calculate the price, where is the price? Any price that you're actually going to pass here to calculate the actual price for it, you can just multiply it by the tax rate. Or we can just create a method for the selling price. So I'm going to come here and I will call it public. This time, this is not going to be static. It's going to be double selling price. And the selling price for every single book is simply going to equal return the price multiplied by the tax rate. Where's the tax rate? Here's the tax rate. Let me copy it. Go all the way down, multiply that by the tax rate, and put semicolon. Now, let's say here, if I want to have access to the tax rate in the main function, just because it's public, it's a private, sorry, I will not have access to it. So I'm just going to come here and create a method. We'll call it public, but this time this is going to be static. Static, and it's going to return a double. And I will say get tax rate. And this method simply will return tax rate. Semicolon. And what are you complaining about? Change it to get tax rate. Yeah, that's what I did. Oh, no. That's not what's supposed to be. It's supposed to be book dot tax rate. No, did I misspell it somehow? Oh, well, look at this. I misspell it here. Tax rate. So this is tax rate, and this is tax rate. Now, since it's a static method, it's recommended to use the keyword book, which again represents the class, not a keyword, sorry, the class name to be associated with the static members. So if I go back to my main method, for each one of those books, I can actually, let's copy this. And we'll say here, what do we have? We have the selling price. So dot selling price. So that will tell me what is the selling price for book 1, book 2, book 3. And same thing for book 3. And if I want to have access to the tax itself here, let me just copy one of those system lines. Because again, it's private, I cannot have access to it directly, but I can have access to it by typing the name of the class dot get tax rate. And that will give me access to. And I want you to pay attention to this part very, very clear. When you call non-static members, you call them by using the object name dot, and you call these non-static members. But when you want to call a static member, you have to start with the name of the class itself, book.get tax rate. Now, if I run it, I just want to see the prices and the rate at the bottom. And you can see here, those are the prices. Of course, one of them was 0, so that's the actual price. And wait a minute, I think I miscalculated something. This should be price plus, price multiply plus the price by the tax rate. It's because the original price plus the tax that you paid for it. So that should fix it. Let me just go ahead and run it again. And here it is. That makes more sense. For a book of 34, it's going to be 39. And for a book that was $70, it's going to be $78. And here's the tax rate, 0.1. So that was the first static data member. Now let's create another one, which simply is supposed to count how many objects we're creating out of book. So I'm going to go private again, static. And this time it's going to be integer, and I will call it book counter. And I'm going to set the book counter, of course, to 0 at the beginning. And here's what you do. Since I'm going to try to trace how many books I'm going to be creating, I need to go at the end of every single constructor, okay, dot book counter, and increase it by 1. So if you create a book using the default constructor, it's going to be increased by 1. If you go create a book using any of the other constructors, it's simply going to increase it by 1. Now, because again, the counter itself, it's a private, if I want to have access to it, I need to have a getter for it again. So public static. And this time it's going to return an integer, and I'll say get book counter. And this simply is just going to return book counter, semicolon. Now, if I want to know how many books did I actually create in my program, all I have to do is get here, Control V, book.get, and I will say book counter. And that should tell me how many books. And again, since I created 3 books, B1, B2, B3, I should see the number 3 printed at the bottom of my program. So this is, again, what we mean by static members. You have to put that in your consideration. When you work on a class and you're creating data members, some of these data members are going to be static, some of them are going to be non-static. The only way for you to know which one of them is static and non-static is if you're talking about a property that simply belongs to the whole class, then that should be static. And if you're talking about a property that every single object will have his own value for that property, then simply that's a non-static. Like, for example, here, the tax rate is going to be the same for all the books. So that's a book. And then the counter here, it's not like every single book will have its own counter. No, we want to have a counter for all the books that we're going to be creating. So that's why we're going with a static for the book counter. And that's simply what we mean by static and non-static members. Feel free to stop me at any point if you have any questions, of course. What I'm going to go through right now, I'm going to leave this example on the side because I want to demonstrate something that it's related to Java programming in general, not necessarily just classes. But I need to demonstrate it for you guys so you'll understand it, because this is somehow related to the same example that we talked about last class when we talked about creating objects and assigning objects and comparing objects. So let me see if I have it here. I still have it here. So let me close this, save it. I'll get back to this later. Okay, so here we go. Oh, I see a question. Can you please explain again the difference between static and non-static members? Okay, that's very easy. Let me, I'm just trying to think about an example, another example that, I'll give you an example here. Let's imagine I have a class and I called this class students, okay? So in this student class, I simply created, let's say, 5 students. And as I'm describing each student in this class, I decided that every single student here will have a wallet. And the wallet is the place where that student save his money and keep his money there. So when I'm going to create student number 1, student number 2, student number 3, and 4, and 5, and 6, every student will have a wallet. And the amount of money in that wallet will be different from one student to the other. That's, again, what we mean by a non-static member. Now, I want you to imagine if I decided to bring a jar to that classroom or those students, and I ask for contribution for each student in that jar. And that jar is simply going to be used to pay for class expenses. Now, that jar by itself, it's going to be treated as a static member because it belonged to the whole class of students, it belonged to the whole class of the students. So the jar itself belonged to the student class. And what's very, very important to understand here is that it's not like every single student will have his own jar. No, that's not the case. The class students will have a jar. So that jar with the money that I collected by the contribution of the other students is going to be owned by the class itself. And it's not going to be like every single student will have his own jar. Every single student will have his own wallet. And a wallet, again, is a data member, a non-static data member. And the amount of the money inside each wallet, again, belongs to that student. But when I created a static member, that is the jar, and that jar is going to hold some money, that money doesn't belong to each student. It's not like, again, it's not like every student will have his own jar. No, it's a single jar that's shared by the whole class. Is that example clear a little bit? So if I want to apply that same concept to the previous class that we had here, I'm going to go to the bookstore here, and I'll tell you here, for example, this book counter as a data member, it belonged to the whole class book. So the books that we're going to be creating, again, will have a counter. And it's not like every single book that we're going to be creating, like those books that we created, B1 and B2, B3, it's not like every one of them will have a book counter that counts how many books there were created. That doesn't make any sense. But having one data member here to count how many books we created, again, makes this data member more of a static member that belongs to the whole class better than, again, as I said, doesn't and it doesn't even make sense to create a book counter as a non-static member. I hope that made a little bit of sense. And if it's not, let me know, please. Is that a yes or a no? Okay, I see the thumbs up. Okay, so let's get back here. Let me close this, and let's get back here. What I'm going to show you here, I'm going to show you an example that is very, very important to understand. And this is a tricky question that you get asked a lot in interviews. I'm going to create a method inside my main class. Now, this method here has nothing to do with the class itself. Okay, the testing class that we created the other day has nothing to do. So I'm just going to come here and create a public static. We'll go with void, and I will say demo ref. Okay, I'm just trying to demonstrate something here. Okay, and I'm going to copy this and go down, put it here. Okay, and we'll go down. Now, what I'm going to come here, I'm going to say integer x, and here, very, very important, I'm going to say testing class t. Okay, it may not make any sense for you right now, but just wait for me and I'll talk about that. So I really don't care about what's going on here in this area here. I'm just going to go straight down here and try those two methods. Demo ref with integer x and demo ref with a testing object t, just t. So if I come here and create an integer, let's call this one x, and let's set x to 100. Now, what I'm going to do, very, very important, I'm going to call this method here. And I am going to pass x. And to save you from the confusing of having x here and x here, let me just explain that. This x here is what we call a parameter. And the x here, the parameter x here in this area, it's going to be alive as long as this piece of code is executed. And this x is a different variable. So every one of these x's is in a different scope. That's what we mean. And different scope simply means they are two different variables, even though they share the same name. I'll explain that in a little bit details in a sec. So what I'm trying to say here, I'm going to show you a fact about Java. So I'm going to come here and say before and I'll put show me the value of x. And here I will say after show me the value of x. Come on. And I'll go after. Now what I'm going to do here, in this method here, the demo ref, I'm going to call, and let me just change this to be demo ref integer and demo, oh, sorry, not demo primitive, and this is reference. Demo reference test. Well, you know, it's a reference. I'll just go this one, demo for primitive data members, and this is demo for references. So here's what I'm going to do. I'm going to come here and say x equal x multiplied by 10. Okay, now just let me explain what's going on here. I created, oh, wait a minute, why is he complaining? Oh, I changed the name. Copy the name here and go down. So at this point, I created a variable called x, which is an integer, and I said show me x. And then I created a method called demo prim, and I'm passing x. Now x here, which hold the value of 100, is simply a copy of x is going to be passed to this x. Okay, so what's going on in the memory? In the memory, there are two variables now equal, they're called x. One of them is here, and another variable called x, which is this one. Both of them, again, are in the memory. What's going to happen? A copy of 100 is going to be passed to this x, and then I'm going to be multiplying it by a 10, so the final value should be 1,000. Now, when I'm going to come back here and I'm showing me, show me x after I call this method, you would notice that it would not change. Let me just show you that. So before and after, it's 10. It's 100. So if I come here, well, so you may ask the question here. So you passed x from here and you passed it here and you modify it. But when you went back, that change that we applied here wasn't reflected on this x here. And the answer will be yes. And the reason why it's that way is because Java follow what we call pass by a copy. Pass by a copy simply means that I'm passing a copy of the 100 and I'm giving it here. And I want to give you an example here so you understand what I'm talking about. Imagine I have a document, and in this document, there's the word 100 in it. And I give it to you. I didn't give you the original document. What I did, I gave you a copy of it. And you decided to write another 0 in your copy. Was that reflected on my copy? And the answer will be no. And this is exactly what's going on. So any modification will be applied to this x here will not be reflected on my copy. But this is not going to be the same when we use test classes. Let's see how test classes are going to work. So I'm going to copy this. And I'm going to go down. And I want you to pay attention to what I'm going to do here. Instead of x, what are we talking about here? We do have this object, testing objects. We have how many of them we created? T1, T2, T3. Let's go ahead and use T3. So T3 dot get x. Show me that before and show me that after. So T3 dot get x. Okay. And I'm passing here T3. Now remember here, I have a method for T3, which is demoref. So let me copy demoref. And let's put demoref here. So what I'm going to try to do here, I'm going to try to update the value of x that I have here. So all I have to do here is to set the x to a new x. So I'm going to come here, and it's going to be a little bit long. I'm going to create a new integer. I'll call it x. And then x is going to be equal t dot get x multiplied by 10. And then after that, I will say t dot set x to whatever x that I have here. So I'm passing t here, which is again t3. And then t3 here, I'm going to get the x multiplied by 10 and store the value in x here, which is going to be 1,000. And then I'm going to set x to 1,000. Now let's see how is this going to work after I run it. And look what just happened. Well, now I see the effect actually is kept in x. So before, I didn't see the change like reflected back on my original object, but here it's actually reflected. So you may ask the question, what's going on here? Why with the primitive data type, it wasn't acceptable, like it didn't reflect in my original copy, but with references, it was reflected. And that goes to the fact, very, very important. And if you remember last class, I hope I didn't delete it. Discard the change, cancel. Let me save my, share my document since it's still there. So this is my document that we talked about last class when we said there's T1 and T2 and T3. So I want you to focus on T3. When you pass T3, do you see this T3 that holds the address of C1 and B? When you pass it to the method demo ref, what you're actually passing, you're passing the address. This is what you're passing to T. So what's going to happen, what you're going to end up with in the function, you're going to end up having a space inside the memory. It's called T. And T will hold the value of C1B. And C1B, again, as you guys remember, is simply referencing, where's the area? Here it is. It's referencing this area. So if you modify X, using T, oh, this is actually T, or using T3, both of them will have the same effect on the same spot inside the memory. And that's how I was able to see the reflection on the results back into my method. Now, let me just go back to my Eclipse. And let me just get back to this point. Java in general, because again, this is a tricky question that a lot of interviews like to ask. Since Java passed a copy, remember here, Java only passes copies. So I pass a copy of X, and here, when I pass T, I'm passing a copy of the address that T3 is holding. And because I'm passing a copy of that address to T, that simply means T and T3 are referencing the same spot inside the memory. So whether the modification is done using T or T3, the same object will be reflected by that modification. And that's why when I said print before and after for non-primitive data types, I was able to modify it and see the results reflected back inside my main memory. But with primitive data types, that's not the case. And this is simply what we have here. X, any change that happens to X will not be reflected on the original X. And for that reason, if you want to have the same effect of those references on a primitive data types, you simply have to convert you have to create a class for your primitive data type to be treated as an integer. So instead of creating an integer X here, you can create a class called myInteger, X equal new my integer, and you pass the value 100 to it. So that simply means you have to create a class for that. And once you do that, after that, you can actually get the same effect that we were talking about here. So this part here was very, very important to understand here. What is the meaning of passing primitive data types versus passing referencings or non-primitive data types? The key here is if you pass a primitive data type and you decided to modify that primitive data type in your method that you're using, simply it will not be reflected on the original copy that you have and that you passed. But the moment you pass a reference or a non-primitive data type to a method, any modification that will be applied to the object inside the method will simply be reflected back on the original copy that you passed to that method. And that's, again, what we mean by passing references as arguments. Is there any questions so far about this part? I'll make sure to post a lot more videos just in case you guys need more in addition to those Zoom meetings. It should help a little bit. Now, my other point that I want to talk about here, which is what we call overload methods. Overload methods, the concept of overload methods, we already talked about it a little. We saw it, but we didn't talk about it. And I'm just going to go straight back to the book class. What is overloading methods? Overloading methods is simply when you use the same name of the method for multiple times, but the difference between those methods is the type and the number of arguments that you have. That's what we mean by overloading methods. Now you may ask, what? Well, okay. Overloading methods is simply when you create multiple methods that share the same name. Okay? But they are different by the number and, the type of the arguments. That's what we mean by overloading methods. And here we got a concept of overloading constructors. You see I have a constructor here, constructor here, constructor here. They all share the same name, but the difference between them is simply what I have between those parentheses. Here I have nothing. Here I have one string, and here I have multiple parameters. That's what we mean by overloading methods. Now, you have the right to ask me, what is the point of overloading methods? And I will show you that in a sec. I want you to imagine you are working on a class, and in this class, you are trying to get here. Let's take this one as an example. Demo for prime and demo for references. But before I get to that point, imagine the following. You want to create a program for someone, and in this program, it's supposed to add numbers. That's the whole job of that program, just to add numbers. Now, what are you going to do? You're going to create a method to add integers, another method to add strings, another method to add doubles. And basically, when you do that, if somebody's going to come to you and tell you, well, this is what I want. I want a project. I want a program that will add anything you give to it. And you decided, okay, that's easy. I'm going to create you a program. And this program will tell you, if you want to add integers, there's a method called add integers. If you want to add doubles, there's a method called add doubles. If you want to add strings, there's a method called add strings. And you know what? Let's just do it right now. So it's going to be public, static, integer, add integers. And in this case, I'm going to pass integer n1, integer n2. And this method simply is going to return n1 plus n2. Okay? Now, let's go ahead and do the same thing. If you want to add two strings, simply is going to return a string. And this is going to be string n1, and this is going to be string n2, and I'm going to call it add strings. Now we'll do the same thing here. Control V. Add doubles. And we'll change this to be add doubles. And this, of course, is going to be double one, and this is going to be double two. Double two, and then it's simply going to do the same job here. N1 plus N2, N3. Now, if I want to use those methods, I can come here and say system print line. Let me just go ahead and do that. And I'll say here, add integers. And I'm going to pass, let's say, 5 and 8. Let me copy that. Control C, Control V. Add doubles. And we'll just add 5.9, 8.5. And finally, add strings. And instead of here, we're going to be passing, for example, B, and this is plus. Okay, so everything looks normal. I have three methods. One of them is called add integer, add doubles, add strings, and one of them I'm passing 5 and 8. The other one I'm passing 5.9 and 8.5. And the other one I'm passing two strings. Now, if I run it, it's simply going to show me those values, as you can see here. So that's simple. Now, I want you to think about it from a user perspective. You decided to go to a company and asking them that I want you to give me a program that's supposed to add whatever you give it to it. And you decided to sit there and tell them, if you want to add two integers, you have a method called add integers. If you want to add two doubles, you call a method called add doubles. And if you want to add two strings, you have a method called add two strings. If you want to add two cars, you have a method called add two cars. If you want to add two boxes, there's a method called add two boxes. Okay, that is one way to get the job done, but there's a way, much easier way, that the user simply will like your presentation, your work, and you just simply can tell him, there's a method called add that will accept anything. So if you want to add anything, just call a method called add, and it will take anything and add them together. So from the user perspective, he will choose the one with the simplicity comparing to your class, that your project that contains many, many methods, and I have to worry about which one I'm going to be calling. Instead of that, it's a single one. Call it and it will work. So how do I apply that concept? It's very simple. All you have to do is to apply the concept of overloading. Overloading simply means multiple methods that share the same name. So this is what I'm doing. I'm taking anything that makes it. So it's an add, add, add. Same thing. It doesn't matter what is the return data type. Let's just put it that way. So no matter what is the return data type, that's not a big deal, as long as they are all sharing the same name. But what is the very, very important part is that the arguments that you have here, the parameter store that you have here, they have to be different. Okay, so you can see here, I have two integers, I have two strings, and I have two doubles. So back here, what's going to happen for the compiler? The compiler will simply look at this is add, this is add, this is add. So which one of those three adds I should call? The one that matches the arguments with the parameters. So what do I have here? I have 5 and 8. They both of these numbers, they don't have decimal point. So this is going to be executed. Let's look at here. I have 5.9 and 8.5. Well, both have decimal points. So this is going to be the matching here. And then after that, what we have here, we have a string and we have a string. And this is where we have a match here. So based on that, I was able to, like, again, the user, whoever bought your program, he's not going to see this. What he's going to see this. It's the same method, add. One time I'm passing integers. One time I'm passing doubles. One time I'm passing strings. And it's all working with no problems. So that, for me, is the best solution. And what I just showed you here is what we call overloading methods. The same concept is simply used here in the Java class. You see, this is a book. This is a book. And this is a book. They're all books. But what's the difference between them is what you have between those parentheses. Nothing here, a string here, and multiple parameters here. And this is, again, what we mean by overloading constructors or overloading methods. Okay, now the last part that I'm going to be talking about, which is very, very important, it's what we call method chaining. And after that, I'll be left with one last point, and this chapter will be covered with no issues. So let me just talk about what is method chaining. Method chainings is it's a way we can use to connect multiple methods together. So when you call them, they're going to look like methods that are chained together. And again, is there a reason for it? Beside the readability of your code, it's really not going to make that much of a difference. But sometimes, and I've seen that I worked on Android applications for a period of my time way back in time, like 12 years ago or something. Method chaining was heavily used in Android applications. The idea of method chaining is sometimes you want certain number of operations to be performed at a certain order. So you might want to use method chaining to force that order. But it's not necessary, again, to be always that way, depending on the application itself. But method chaining, again, in general, it's a way that you can allow you to call multiple methods, one after the other, in a single statement. And now you may ask me, so how is that? I'll tell you. Do you see this example here? When I decided to change B2, the title, the author, the price, the ISBN, the number of pages, and the publication year, I did every one of those set methods in a different line. Method chaining will allow me to put them all together in a single line. So you may ask, how is that possible? It's a very, very simple modification that if I apply it, I will be able to do that. And you will have, of course, the freedom to go with using any format you like. So I'm going to show you that it will work in both scenarios. So based on what I'm saying here, it looks like those settings are going to be my candidate to demonstrate method chaining here. And again, method chaining, it's not like something has to be implemented, but it's available and it's there. So let's go back to the books. I'm going to go to all the setting methods. So let's start with set the title. Set the title, as you can see here, has no return data type. What I need to do to convert it to the method chaining implementation, I need to change the data type to be book. The same data type that we have. So the same class name. So it's going to return a book. And you have to go down here and say return this and put semicolon. So the only chain that was applied to those settings, first of all, instead of returning void, you're returning the object book. and you change, you have, since you're going from void to book, then you have to return something, and that thing is simply the book itself, this. So that simply means I'm going to come here and change this one to be book. Let me copy this line because I'm going to repeat it again. Control V. Control V, and of course, book. And book again. Turn this. Book. Turn this. And finally here, book again. And at the end, return this. Semicolon. Now, with all the changes that I applied, if I go back to the main class, you see here, no effect whatsoever. So if I run it, it's simply going to work with no problems, with no issues, all the way to the end. Now, what I'm going to do, I am going to make a copy of this. And I'm going to go down here. And I'm going to comment this section here just to show you that I will get the same effect. Now, let's look into book 2. Where's book 2 here? Book 2 is Rich Dad, Poor Dad. And here is Rich Dad, Poor Dad, Adam, year, price, number of pages. So this is, again, book 2. Now, look what I'm going to do. I'm just going to come here. And I'm going to do the same thing here. And I'm going to come here. And as you can see here, this is, again, what we mean by method chaining. Okay, so this is, again, what we mean by method chaining. And as you can see here, you start with the name of the object and then dot, set the title, dot, set the author, dot, set the price, dot, set the ISBN, dot, set the page number, dot, set the publication year, and so on. Now, if I run it, you would notice that nothing will simply change. I'll get the exact same results. Where is it? Rich Dad, Poor Dad, and everything is the same. That's what we mean by method chaining. Now, the reason why I said the order might be important here, and let me just give you an idea here. Just imagine, for you to be able to set the author, the results of setting the author name relies on whatever is going to be returned from setting the title. So what is that supposed to mean? Go back here. Imagine after you set the title, again, this is not the case in this example, but sometimes imagine there are some calculations that will be done here. That calculation will be reflected on the author that's going to be selected for the book. So since it's important to set the title before you can actually set the author, method chaining could be, again, a way to show that this has to be done first and this has to be done second, and to force it that way. And as I said, this is not the case all the time, but sometimes it is the case. In this example, of course, we really don't need to worry about that. But in general, sometimes it might be the case where you actually need to put them in a specific order. Now, the last part of this chapter is what we call the UML. Now, UML, it's your best friend. Let's just put it that way. UMA, it's a technique that we have to present, and I'm going to say this again, to present a class in a graphical form that will summarize the whole class to you. And by a look at a UML, you should be able to read it and know how to interpret it. And then after that, you should be able to convert it back to a class. So in this class that we have today, I had a UML, but it's not exactly the same match because I did a lot of changes compared to my original copy. So the UML I'm going to show you here is not a perfect match for what we have here, but I can modify it to make it a match, of course. So let me just go ahead and show you that. I already created it, so that should save me some time. But I'm just going to copy it and paste it directly. So let's go ahead and do that. And here we go, Control V. Look at this. This here is what we call a UML. As I said, it's a graphical presentation for a class. And this UML, in general, UML, sorry, are formed in they're presented in a form of a table. And in this table, we mainly have many sections, as you can see here. The first section at the top represents the title of the class, which is a book. The second part represents the data members. Okay. And for the data members, you will see the sign here negative, as this is a private data member. So the title is a private, author is a private, public is a private, ISBN, price, number of pages. They are all private data members. And it's telling me what is the data type for each one of them. So the title is a string, the author is a string, the publication year is integer, ISBN is string, price is double, number of pages is an integer. Right after that, you have a list of public methods. And those public methods, as you can see here, we have a plus. Plus simply means those are public. What do we have here? We have a constructor. Now, in my class that I showed you, I have 3 constructors. And here, I'm just showing you one of them. So if I want to actually add the other ones, I should be adding them here. I have the getters and the setters. And instead of me showing you all the getters and the setters, I'm just showing you, well, I'm not showing any of them here, actually. Okay. And actually, as I said, that there's a lot of what you see here is modified. It's not exactly this. For example, get the total books, and instead of total books, what did I call it? Book counter. Yes, it's a book counter. So instead of total books, it's a book counter. And here he decided to create it here. It's not, should not be here. I'm just going to cut it from here. And it should be here. Go ahead and put it here. And this one will return an integer, and it's a static. Of course, we have another static member that I didn't put it there. But again, remember here, this is, again, my original copy, so it will look a little bit different. So we got another static member to return the tax rate. So let me just copy it and go ahead and do that. Get tax rate. And the tax rate was double, I believe. So I'm just going to change that to double. Okay, now we got the toString method. We have equal display. Well, there's no display. We actually had a toString method, so there's no need for this. Calculate the tax rate. Oh, this is tax price. This one, yes, we had that one. I call it calculate tax, or I call it calculate selling price. So I was going to change that to selling price. So it just matches with what I have here. Control V. And well, you don't need to pass the price because the price is simply known. So we're just going to selling price. I'm just trying to make it to match with what I have here as much as possible. What you should know here that I need to have all the constructors that I have to be posted here. And I also need to have the setters and the getters added here. Let me see what else we have. We have the selling. We added those. We have the toString. I did equal. So yeah, so what's missing here is just the setters and the getters and the Boolean expression book. So I'm going to come here and do that. Since we are in the subject book, no arguments. And we have another one. Plus book. And the other one has a string. And I think it was the title. Here it is. Yes, it is the title. So title string. Gonna try. And I'm not going to do the setters and the getters because that's going to simply take forever. But you got the idea here. So I'm just going to come here and just say, add the setters and getters. Now, why is this important? In reality, when you're going to be given a class, probably the class will be given to you in a form of a code, of course, but that code is going to be contained in many, many pages and thousands of lines of code. So to have an idea about a class and what's inside a class, reading the class itself with the code, with the lines that you have there, it will take forever for you to have an idea, a general idea about what this class is all about. But if you have the UML for any class, just for as a quick look at it, you'll be able to have a really basic idea about what does this classes consist of, and what do we have here. And as you can see, many of these classes, basically, then like especially those methods, you probably would not know what do they do. But again, you can at least guess selling price equals toStrings. With experience, you should know what is the toString is doing, what is the equal is doing. Selling price, again, you can guess what it's doing. Those are, again, static private members. Oh, by the way, how do I know it's a data member or a method? Data members, they don't have parentheses. Method members, they have parentheses. So when you see here tax rate and total books or book counters, that's what we called it. So let's go ahead and do that. Because they don't have parentheses at the end of this, you know that these are data members, but those here, they have parentheses and they're public, and we have methods here. So being able to read a UML is a very basic and essential skill that any programmer should know, especially in Java. And in a lot of cases, you may find yourself dealing with somebody still is giving you the UML and asking you to convert it into a class. Now, in a lot of cases, when you've been given a UML, you're simply going to be looking at most of the methods. For example, toString method, I don't need to tell you what to do with toString method. You should know how to do it by yourself. Equals, I don't have to tell you what equals going to do. I don't have to tell you how the books are going to work. I don't have to tell you how the adders, the setters and the getters are going to work. All of these should be known for you. Maybe you may be confused a little bit about the selling price, but I'm guessing here you can ask about it, or you may get some extra instructions about what's supposed to be done here. And here, get the total books, get the tax rate. Those are, again, self-explained methods. So the implementation of each one of those methods, again, in a lot of cases, most of the time, it's something that it's either you should know how to do it without somebody telling you how it's supposed to be done, or you can guess what should be the final output of a method that is public that's called selling price that returns a double. Well, simply it should tell me what is the selling price of this object. So by looking at these, we got a price here and we have the tax rate. So that should tell me that how am I supposed to calculate the selling price? So what I'm saying here, that the UML, it's a compact presentation for the class that a good programmer should be able to read it and extract every single piece of information that he may need to convert it from this graphical presentation to an actual code. And I'm gonna try to give you guys some exercises in the future where I'm gonna give you a simple UML and I'm gonna ask you to convert it to a class without giving you any hints. Here it is. Try your best and tell me what you're gonna think about it. Okay, so with that being said, I'm going to post those codes, of course, later into Canvas page, so you'll have access to them. We have those two objects that we talked about, the main class with the reference examples and the overloading, and we have the book class. If I want to say something about classes, I want to say that this is a very important concept in programming. And understanding objects and classes and how they work, how the programming language deal with this concept is a big deal. And the thing is, every single programming language deal with classes and objects in a different way. C++, for example, do it in a totally different way comparing to Java. So it's extremely important to understand this concept, because in reality, any application that you're going to be dealing with is simply an object-oriented programming. So if you're going to go and work for a company to create applications, systems, 100% of the time, it's going to be about classes and objects. And those small details play a major role in producing an efficient project that simply will work perfectly fine. So I can say that until this point, we covered one of the things that I want to tell you here. The book that we're using, sometimes the book likes to call things in a different, like every single book used to like to use different references and name things differently. So I was just looking at the book and the assignments, exercises. There's the drive class. Most of these concepts, again, if you just go and read about them, we probably mentioned them here in using maybe a different term or something. So don't let the terminology sometimes fool you to think that, oh, I'm missing something. Sometimes it's the same concept that has multiple terms. So it's just a matter of you reading about that term and you'll find out, oh, I already know what it is. Okay, so let me stop sharing my screen. And I am done at this point. So I am going to stop sharing, stop recording.